Note 7.4, adding and subtracting rational expressions. What does a rational expression mean? Rational means a fraction, something you can write as a fraction, and an expression is without an equal sign. How do you add or subtract rational expressions? You need the same denominator. What are the steps for adding or subtracting rational expressions? The first step is to factor the bottom. Second step is to get the same bottom, same factors on the bottom. And the third step is to combine the top. Combine the like terms on top. Example 1. Are the denominators the same? Yes. So we'll just keep x plus 3 on bottom. And then I'm just going to write the top, x squared plus 4x, distribute the negative. So that's going to be negative 4x minus 9. Combine the top, so combine like terms on top, so that's going to be x squared, and these cross out, minus 9 over x plus 3. And this is just a normal rational expression. Factor this out. So this is going to be x minus 3, x plus 3, and x plus 3 can't factor anymore. These cross out, and your answer is x minus 3. Example 2. Okay, so the denominators are not the same in this case, so we're going to have to factor the bottom. They're factored already. Then I'm going to get the same factors on bottom. So right here, is there an x plus 4 on both the bottoms? This one does not have an x plus 4, so I'm going to add an x plus 4. Whatever you add to the bottom, you add to the top. Now, at x minus 4, there's this fraction does not have x minus 4, so I'm going to add it to the bottom here so I can make it the same. Once I get it the same, I just keep one of the bottoms. So it's going to be x minus 4 over x plus 4. Okay, I'm going to distribute the 3. 3 times x is 3x. 3 times negative 4 is negative 12. I'm going to distribute the negative 2. I'm going to combine like terms on top. So 3x minus 2x is 1x. Negative 12 and negative 8 is negative 20. And then I'm going to factor. Nothing crosses out. So my answer is what's left. And usually you multiply this out. X minus 4 times x plus 4 is x squared minus 16. Example 3. The denominators are not the same here, so I'm going to go ahead and factor. This factors to x minus 1, x plus 1. And now I'm going to get the bottoms the same. There's an x plus 1 on both the fractions, so I don't need to add anything for the x plus 1s. This one has an x minus 1, but this bottom does not, so I'm going to add it. Whatever I add to the bottom, I add to the top. So keep one of the bottoms, because they're both the same. 6x plus 4, I'm going to take the positive x, and distribute. Positive x times x is x squared. Positive x times negative 1 is negative 1x. Combine like terms on top. There's only an x squared, so nothing combines with that. 6x and negative 1x is 5x plus 4. This is a rational expression, so I'm going to factor the top, see if anything cancels out. What multiplies to 4 and gives you 5? 4 and 1. So this turns into x plus 4 and x plus 1 all over x minus 1 times x plus 1. X plus 1's cancel, so our answer is x plus 4 over x minus 1. Alright, next page, page 12. Right here, this is a complex fraction, so this means divide. So all I'm going to do is rewrite it. X plus 2 over x plus 4, and this means divide, so I'm going to write divide by x minus 3 over x plus 4 plus 3 over x plus 5. When you divide, you multiply by the reciprocal, and we flip the second one after the division sign, so it's x plus 4 over x minus 3. And when we multiply, we don't need the same denominators. We just got to make sure they're factored. Right now, plus. So these x plus 4s are the same, so these cancel out because we're multiplying, so we don't need the same denominator. So what we have left here is x plus 2 over x minus 3 plus 3 over x plus 5. Now this is an addition problem, so when you add and subtract, you need the same denominator. So we're going to factor the bottoms, and they're factored already. We're going to make sure that they have the same bottoms. So does both fractions have an x minus 3 on the bottom? No, this one does not, so we're going to add it here, x minus 3. And this one does not have an x plus 5, so we're going to add it here, x plus 5. So we got the same denominators, so we're going to work with the top. We're going to multiply out the top. So I got x times x, which is x squared, x times 2, which is positive 2x, 5 times x, which is 5x, 5 times 2, which is 10. Take the positive 3, distribute. 3 times x is 3x minus 9. All over, and just keep the same factors on bottom. So we got x plus 5 and x minus 3. We're going to combine like terms. So we got x squared, 2x, 5x, and 3x is 10x plus 1. We got x plus 5 and x minus 3. Try to factor out the top. Anything multiply to 1 and give you 10? No. So none of the factors cancel out, so that's your answer. Example 5. 5 over 12x plus 1 over 2x cubed. Now this example is a little different because on the bottom you don't have any pluses or minuses. So when you factor these out, these will be like one factors. So when you add, you need the same denominator. So we're going to factor the bottom. Break down 12 until you can't break it down. So 4 times 3. And then this would be 2 times 3. And bring down the 3. Bring down the x. Break down the 2. You can't break it down anymore. X cubed is x times x times x. Okay, we're going to make the bottoms the same. I have two 2's here, so I need a 2 here. And I don't have a 3 here, so I'm going to add a 3 here. And I have 3 x's here, so I need 2 more. So a short way to write that is x squared. Now that the denominators are the same, we're going to multiply out the top. So that's going to be 5x squared. Take the positive 1, distribute. 1 times 2 times 3 is 6. All over, and just keep the same factors on bottom. So we got 2 times 2 times 3, which is 12x cubed. Can't factor anymore, nothing cancels out, and that is your answer. Thank you for listening to Notes 7.4, adding and subtracting rational expressions.